stop.
Hello viewers, welcome to my class. In today's class, I'm going to show you how to draw a standing wave pattern in a closed pipe. So, to start with, what is a standing wave? You see, this standing wave is formed as a result of one of the properties of wave, which is interference. So, a standing wave is a kind of a vibrational pattern created within a medium when the vibrational frequency causes the reflected wave from one end of the medium to interfere with the incident wave, such that along the line, a particular point, right, appear to stand still. That is where it gets its name, either stationary wave or standing wave. I hope you are getting it. Now, the point which appear to stand still, a point of no displacement or no movement of what? Of the air column, is said to be a node. While the point where there is a maximum displacement of the air column is said to be what? Antinode. So it is this node and antinode idea that I'm going to use to give you a simple logic. Let's get started. Now, let's talk about open-end air column. I have an open pipe. When I say open pipe, a pipe in which both ends is open. For instance, what I have here now is an example of what? Example of open pipe. Here is open, here is also open. But when I have a kind of pipe where one end is closed, example of that is just like this, my marker. My marker here is an example of what? A closed pipe. One end is closed, one end is what? Is open. This is what? A closed pipe, while the other one is what? Open pipe. Now, the first vibrational mode of vibration that you set up in this open pipe is said to be the fundamental frequency. Every musical instrument, every material has their what? Has their fundamental or natural frequency. The frequency or the mode at which they vibrate on their own without any external forces. Is that clear? So now, that first mode of vibration, which we call fundamental frequency, is the most audible, but what? The lowest frequency. Are we getting it now? So the first vibrational frequency, the fundamental, has only one node. Only one point where there is what? Where there is no displacement of what? Of the air column. Are we clear? So now, I will just locate any point here within the middle precisely as my node. So if I pick here as my node, now I can decide to take my incident wave from this side where my reflected wave will go round. So I'll follow the what? The midpoint of this. Here is my incident mode of disturbance through that end. Then from the end of this, the reflected wave will go this way. Are we getting it now? Here is my first setup. So let's take here to be the length of the air column. This point where there is interference between the incident and the what? Reflected. This is known as what? Node. This is the point that appears what? Stationary. It's known as what? The node. So here is the node, and the end here is the antinode where I have what? Maximum displacement of the air column. Are we clear? Good. Let's take this as the length of the air column, right? Now, the distance between a node and antinode I want to give you a short way to get it. Don't need to cram what is the distance between node and antinode. Just take, for instance, in a string, a full wavelength is like this. Here is the reflected. Here is the what? The incident. Here is the what? Reflected. From this end to this end in a string, here is the node. Here is the node, right? And this here, from here to here is your lambda, the wavelength, the distance between two successive what? Crest or the trough of what? Of a wave. Now, if that is the case, from here to this place is half of the what? Of the wavelength. So I have lambda all over 2, which means from this place here, if I divide it to 2, is what? Half of the half, which is what? Quarter. Are we clear? So if you look at it critically, is I have from this place to this is a quarter, just as what I have here is quarter, and from here to here is also what? A quarter. So I have quarter plus quarter, that is lambda over 4 plus lambda all over 4. So I have from here to here as quarter, from here to here as quarter. So I add it together, I'm going to have 2 lambda all over 4. That will give me lambda all over 2. If that is clear, it shows that the whole of the length of the air column here is what? Lambda all over 2. Are we together? So if that is done, remember that you have this basic formula that V is what? F lambda. So from this L equal to lambda all over 2, it implies that lambda is equal to what? 2L. So anywhere I see lambda in this my formula, so V is now equal to F. Lambda is what? 2L. So making F subject of the formula, I have F is equal to divide both sides by 2L. I have V all over 2L. This frequency here is my fundamental frequency. I call it F naught. F naught is equal to V all over 2L. This is my fundamental frequency. I hope it is clear. So, fundamental frequency or my first harmonics. Other frequency about fundamental frequency can be what? It can be harmonics or what? Or overtones. Is that clear? So, for instance, if I have other frequencies such as maybe I have F1 to be 2 F0, 3 F0, 4 F0, all these are harmonics and the same thing as what? Overtones. But if I have other frequencies such as what? 1.2 F0, 3.5 F0, all these are overtones, but not what? Not harmonics, because they are not what? Multiple integral of what? Of the fundamental frequency. They are not whole number integral of what? Fundamental frequency, rather, for more simplicity. Are we clear? So when they are whole number multiples of what? Fundamental frequency, we call it what? Harmonics, right? And the same thing as overtone. But when they are not whole number multiples of what? Fundamental frequency, they are what? Overtones, but not harmonics. Are we clear? Good. This is what we have. Now, if you blow more or disturb the air column more, right, you are bound to set up more what? More standing wave in the what? In the pipe. So that will generate what? Other frequencies other than what? Above fundamental frequency, which are what? Have higher frequency, but what? Most silent and what? Less audible compared to what? Fundamental frequencies. So let's assume we have this. We cause more vibration this time around, so we're going forward the second harmonics. Now look at the pattern. First harmonic, 1 watt, 1 node. Second harmonics, we have what? 2 nodes. So I'll just locate 2 nodes anywhere. Probably try so that the distance will be a bit close or very accurate. So look at first harmonics, one node. Second harmonics, I'm having what? I'm having two nodes. I'll just construct my what? Incident through it, right? And my reflected through it. I have the second setup. Here is what? Is the second harmonics. Now, like what we have just done, remember from this place to this place is like this to this, which is what? Half lambda. So from here to here is what? Lambda over 2. This to this is lambda over 4, right? This to this is what? Lambda over 4. If you add all these things together, lambda over 4 plus lambda over 4 will give us what? Lambda over 2. That is half lambda. Half lambda plus what? Half lambda will give us what? 1 lambda. So which means that the length of the air column here for this setup, the length of the air column here, L, is simple as what? The full what? Wavelength. Remember, we have V is F lambda. So from here, anywhere you see lambda, you put what? You put L. So F is equal to what? FL. Since in this case, we are in second harmonics, but what? First overtone. So I'm going to have here to be what? F1. First overtone, but what? Second harmonics. But remember, I can make here subject of the formula that will give us what? V all over L. And in the fundamental frequency, you have F naught is equal to V all over 2L. Remember that? So if I bring that here now, it shows that I can rearrange my fundamental frequency to be what? 1 all over 2 into V all over L. There's no differences. So, which implies that I can write my F naught is equal to 1 over 2 is the same thing as what? As 1 over 2 into what? What is V over L? That is what? F1. So F naught can be equal to F1 all over 2, which implies I have F1 is equal to what? To F naught. This is the immediate frequency above what? Fundamental frequency, and it's a whole number multiple of what? Fundamental frequency. So that is our what? Our second harmonics, but what? First overtone. That is for this one. We have first overtone is 2 multiplied by what? Fundamental frequency. Let's assume I have here, I cause more disturbance, then there will be more what? More frequencies set up and more standing waves. So now here is the second harmonics. I am going for third harmonics. First harmonics, 1 node. Second harmonics, 2 nodes. Third harmonics, 3 nodes. So I'll just locate it. 1, 2, 3. Is that clear? Then my incident passing through the nodes. Here I have this. The reflected passing through the node. Here I have it. I have my setup. So the length of the air column, L, if you look at this, from this node, here is the node, and what? Node, right? Here is my antinode, 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 antinode. An antinode is the point where there is what? Maximum displacement of what? Of the air molecule, isn't it? Or air column. While here is where there is a constraint, there's no displacement of what? Of the air column. So from this node to this node, I have a full wavelength, which is what? Lambda. And from how I illustrated it initially, from here to this place gives me my what? Lambda over 4 quarter, and also this lambda over 4. Lambda over 4 plus lambda over 4 gives me what? Lambda over 2. So lambda over 2 plus this lambda, all of these set up together, I'm going to have what? Lambda plus lambda all over 2. Please take note. It's very simple. From here to this place, coming back here is just like full wavelength, which implies I'm going to have 3 lambda all over 2. So in that case, the length of the air column is equal to 3 lambda all over 2. So quickly remember our formula that V is equal to F lambda. So I'll make lambda subject of the formula from here. I have L is 3 lambda over 2. If I cross multiply, I have 3 lambda is equal to 2L. So lambda is equal to 2L all over 3. So anywhere I see lambda in this equation, I'll put what? 2L over 3. So I have V is equal to, here, the frequency here is what? Is the third harmonics, but what? Second overtone. So I'm going to have F2 multiplied by lambda is what? 2L all over 3. So this is the same thing as saying you're having 2L F2 all over 3, right? So I have V is equal to 2L F2 all over 3. When I cross multiply, it implies I have 2L F2 is equal to 3V, so that I have my F2 is equal to 3V all over what? 2L. Is that clear? So remember that our F0 is V all over 2L. So my second overtone F2 is 3V over 2L. So this can be written as 3 into V all over 2L, correct? So which implies that F2 is equal to 3, V over 2L is what? F0, 3 F0. You can see the sequence. Here, first harmonics, 2F0. First overtone, 2F0. Second overtone, 3F0, which is second harmonics, third harmonics. As simple as this. I can as well have more of what? Other frequencies, depending on the what? Mode of vibration. Can set more standing waves in the pipe. So if I am going for what? The fourth harmonics now, how many nodes? I guess you get it now. 4 nodes. So I have 1, 2, 3, 4. Just the way I did it, here is my incident passing through the nodes, as simple as this, right? And here is my reflected passing through the nodes. So from here to here is my length of the air column. So the whole of this, let's calculate it again. The whole of this from here I have is wavelength lambda. Now from here to here I have what? Half lambda, lambda over 2. From here to here, half lambda. From this to this is quarter, lambda over 4. From this to this is also quarter, lambda over 4, isn't it? So lambda over 4 plus lambda over 4, that will give us lambda over 2. Is that correct? As simple as this. Good. That will give us what? Lambda all over 2. Lambda over 2 plus lambda over 2, that will give us how many? That will give us 1 lambda. So lambda plus this lambda gives us what? Gives us 2 lambda. Let's see what we have. So in this case, my L, length of the air column, is what? 2 lambda, which implies here lambda is what? L over 2. So from V equal to F lambda, here now, this is what? This is fourth harmonics, but what? Third overtones. So I'm going to have V is what? F3. Now lambda is what? L over 2, which implies I have V is what? F3L all over 2. When I cross multiply, I have F3L is equal to what? 2V, which implies I have F3 is equal to 2V all over what? All over L. If I make V over L subject of the formula by dividing both sides by 2, I have V over L is equal to what? F3 all over 2. From this fundamental frequency, if I make V over L subject of the formula by multiplying through by 2, I'm going to have V over L will be what? 2F0. So V over L, I can equate this. I have 2F0 is equal to F3 all over 2. So if I cross multiply, I have F3 is equal to 2 times 2F0 to give us what? 4F0. You can see for the fourth harmonics, I have what? F0. So if you look at it sequentially, I have F0, I have 2F0, I have 3F0, 4F0, and you can guess the remaining one is going to be what? A whole number multiple of what? Fundamental frequency. So these are the generated harmonics in an open air pipe. So here is the fundamental frequency. Here is the what? The second harmonics, first overtone, third harmonics, second overtones, fourth harmonics, and what? Third overtones. It's as simple as what? As this. This is how we draw the standing waveform or pattern in an open